everyone, this is Yash sir from Aditya Academy, back again with the first chapter in your 9th SSC syllabus, Laws of Motion, and this is lecture number 2 where we will be moving ahead with the ideas of motion. That is, we are going to study more than what is distance and displacement. Now, last time we studied two things. One was distance and the other was displacement. And we understood that by definition, okay, distance is the length of the actual path taken by an object, okay, or while in motion. So when an object is moving from one place to another, as we define motion to be, motion is when an object moves from one position to another. Whatever the actual length is covered by an object is known as distance between the initial, that is the starting, and the final position. Okay, we also took some examples, and based on that, today we are going to start with a few questions right over here. Okay, and let's look at the very first question. We'll solve this and then we will move on to speed and velocity. Let's look at the very first question. Every morning Swarali walks around the edge of a circular field having a radius of 100 meter as shown in the figure 1.2a. If she starts from point A and takes one round, how much distance has she walked and what is her displacement? Now, okay, the first thing that kids or students get confused when they come across this sum is they say, so how do we calculate the circle's outer lining? That is, they are talking about how do you calculate this path. Now, it's very easy, okay. You have come across this formula already. If you have not, this is what the formula is all about. The formula, okay, to find out the distance, that is the path that the person has taken, okay, that is Swarali. Let's focus on first finding out the distance, okay. We'll talk about the displacement later. Let's talk about the distance first. To find out the distance, if you look at it, if you look at the entire circular path, it resembles to a circle. It looks very, you know, nicely put forth a circle. And it has a radius of 100 meter. That means from the center to where she is walking, the radius given to me is approximately, they have given 100 meter. Alright. They are asking me to find out the distance. Now, the distance over here will be nothing but the circumference of the circle. Now, what is circumference of the circle? Circumference of the circle is the entire circular path, okay, which the circle is made of. So let's talk about the circumference of the circle. Okay, let's talk about this sum. Let's get going. Okay, so I will say, as given in this sum, circumference, okay, of circle, the formula is given by 2 pi r. Absolutely right. Yeah, 2 pi r. 2, obviously you know the value of pi. Okay, value of pi is 22 by 7. That is what we're going to use, and that is how you find it. Now let's talk about, let's get going, moving ahead with this sum. Okay, now the entire circular path, okay, she is starting from point A. The radius given to me is 100 meter. I want to find out distance. I will say the distance is equal to the circumference. If circumference is equal to 2 pi r, that makes the distance to become 2 pi r as well. Alright, we already know the radius. Radius is given to me. So what I'm going to do, I'm just going to directly put in the values. So that gives me let's talk about it. That gives me, now we got the distance, we got the formula for distance. Now we're going to find out what the actual distance is. So I'll write the formula right over there. Distance is equals to 2 into 22 by 7 into 100. Now let's go on with the division. Okay, we're going to use the fast method right over here. Okay, so 7 ones are 7. Okay, and then we have 7 ones are 7 again. 10 minus 7, you're left with 3. Goes up top the 0. Okay, then what you have, 7, again you will divide it by 7, so 7 fours are, you have 28, you are left with 2. Now, just because you have a remainder left, you have to add a point, okay, in the quotient. That gives you another 0 that you can be using after your remainder, and then again you have 7 twos are 14, you're left with 6, you can add in one more 0. Then you have 7 8s are 56. Now we stop right over here. I'll tell you all why. Because you do not go more than 2 places after your decimal point. This you will have to follow for your 9th and 10th. Once you move into 11th and 12th, you have, okay, you can go up to 4 values. Now we do not, basically the idea is to not go that deep in calculation because it's not needed. For your level of curriculum or your level of calculation, it's not needed to go that deep. with the calculation. So this much is enough. So yeah, 14.28. Just give me a minute. Yeah, we'll have to cut this part. Yeah, let's continue. Okay, so we got the answer as 14.28 for that division. I'll write the rest of the values. 2 into 22 into 14.28. That gives me 222 is 44 into 14.28. Let's multiply this 14.28 into 44. All right, let's go. Okay, 8 fours gives you, 8 fours gives you, man, I got so confused. 8 fours gives you 32. 4 twos gives you 8 plus 3. 8 fours gives you 32. 4 twos gives you 8 plus 3 gives you 11. 4 fours are 16 plus 1 gives you 17. 4 ones are 4 plus 1 gives you 5. Add one more 0, copy down as is because obviously the second digit is the same to 2, 1, 7, 5. Let's add them up. Okay, you will get 2, 3, 8. 7 plus 5 gives you 7 plus 5 gives you 12, and this gives you 6. The point comes after this, so you get it as 628.32 meters. Now this is your distance. Why in meters? Absolutely, because the radius was in meters. So now you will you will ask me why, sir, in meters? Because the radius is in meters, right? So if the unit of the given radius is in meter, that means the circumference will also be in meter, and that means the distance is meter. Now let's moving on to the displacement. This distance was very, like, it needed a little calculation. Now let's move on with the displacement for this value, for this question. All right. You see, for displacement, okay, we know displacement is the shortest path between starting and final position. Now please pay very close attention. In the question, if you pay attention in the question, they are saying that Surali walks around the edge of the circular field having a radius of this, as shown in the figure. She starts from point A and takes one round. If she is taking one round, that means she is starting from A and ending at A. That means her initial position is A, her initial position is A, and her final position is A. Okay, that means the distance between a starting and the final position is nothing but 0. The reason is the starting and the final position is the same. So automatically you will say displacement will be given as to be 0 meters. That it is. Okay, you just don't have to give much more explanation. If needed, just write over there. Okay, since she starts at point A, or Swarali starts at point A and stops at point A, displacement is 0 meters. Very easy question, very simple. Now this is one more easy question that you have, that we had solved something similar to this car question in the last lecture. Let's look into what this question has to say. If a car starting from point B goes to a point Q, okay, as you guys can see, so it's starting from P, let's mark P. So this is my starting position, okay, and it returns to point, obviously it goes to point Q and then it comes back, okay. How much distance has it traveled and what is the displacement? Simple, very easy, okay. Let's pay attention to this. The car moves a distance of 360. Now we already talked about this in the last class, okay. Distance is a vector quantity, you see. See, distance is a vector quantity. Distance is a vector quantity. That means when, sorry, I'm so sorry, cut this part, okay. Cut this part, let's go. Okay, we already spoke about distance and displacement in the last class, and we understood that distance is a scalar quantity. That means it does not speak about direction whatsoever. Whereas displacement is a vector quantity, it talks about direction, and for y'all, the direction is none other than positive or negative. Positive means moving forward, negative means moving backward. Now, if you compare, if you use distance and displacement idea in this car ka example, you will realize first the car is going from P to Q and then it comes back from Q to P. Let's add that up, okay. We know the distance of this, we know the length of the path, right? So let me first write the length of the path. Okay, so the length of the path given to me is how much? It is 360 meter. All right. Length of the path is 360 meter. Let's talk about the distance first. I will say the distance is first the PQ, and then you add it up with QP. All right. The length of this path is 360. That gives you 360 meter. And coming back again, the person or the car obviously covers 360 meter for going, 360 meter for coming. Now it's the actual path covered, so that gives you 0. This becomes 2, 1 goes up top. You have 6 plus 3 plus 3, 6 plus 1, 7, 720 meter right over there. This is the distance covered by the car. Simple. Now let's talk about displacement. Now you see, displacement has direction. The car first moved in the positive direction. The car first moved in the positive direction. So let's mark that up right over there. Okay, when it first moved to the positive direction, then it came back with negative direction, right? So let's use PQ as positive, let's use QP as negative. Okay, works. So I will say it is PQ, right, plus minus QP. Why minus QP? Because of the opposite direction. That will give you PQ's distance is obviously 360, plus minus becomes minus, and QP is also 360. If you look over there, displacement is 0 meters. Displacement is 0 meters. The reason why displacement is 0 meters is, if you can see, it gives you the answer for the definition. It gives you the answer with the definition. It says displacement is the final, it is the distance between, the shortest path between your initial and the final position. And you can see for this car's example again, okay, you can see for this car's example again, okay, it started and it ended at its at position P. Okay, so the displacement becomes 0. Very easy. Now let's move on to speed and velocity. But before we move on to speed and velocity, let's talk about scalars and vectors. What are vectors? What are scalar? Let's talk about it. Okay, let's talk about scalars and vectors. Okay, now this is a simple distinguish that we will be using to understand scalars and vectors difference. Okay, you see, scalar, okay, are physical quantities which only have magnitude. You see, magnitude is a numerical value along, suppose I give mass for anything, suppose I am talking about a mass of some object. Okay, let's say it is around 46 kilogram. So a magnitude basically means that 56, sorry, my bad, 56 over here means a numerical value, and your kilogram right over here okay, is a unit. Bringing a numerical value and a unit together, you get a value, something called as magnitude. This is what magnitude means. Magnitude is a numerical value with a unit which talks about a physical quantities, and a physical quantity will always have a magnitude. It will always have something to be measured for. Let's talk about vectors now. Though vectors also have, they are also physical quantities which have magnitude, but they also have direction. Okay, so physical quantities which have magnitude and direction. All right, okay. Now magnitude plus direction looks something like this. Magnitude and direction. Let's talk about what magnitude and direction look like. So if suppose I'm giving you minus 43 Newton, in this minus sign right over here is denoting the direction, whether it's forward or backward, whatever your motion will be on, based on that. This thing, this 43 right over here is again becomes your numerical value. And lastly, the n over here, as you already know, It is the unit to measure force. I'll teach you what this, why we use Newton and everything is gonna come up in the chapters ahead, in this chapter ahead, okay? So we'll understand why, but my basic idea is to make you understand just magnitude is this, magnitude plus direction comes with a sign right over here, and that is what vector quantities are. So physical quantities which have magnitude and direction, vector quantities, physical quantity which only have magnitude, scalar quantity, okay? You can write down the examples of them as well. Like physical quantities, the examples are mass, okay, you can talk about mass, then you can talk about distance is a scalar quantity, okay, you can talk about mass, distance, okay, there are many, but I'm just writing so much for the time being, okay. Then for vectors you have a lot, you have force, you have velocity, we'll talk about this, okay. You also have speed over here, speed is also a scalar quantity, I'll tell you why. You have force, you have velocity, okay. Then you have momentum that we're going to talk about in this chapter as we move ahead, okay. You also have acceleration, okay. So we'll talk about all this as we move up ahead, but that's the main answer to this. So vectors and scalars, there's a difference. Which of these quantities, distance, speed, velocity, time, displacement, are scalars and vectors? Let's write over here. Distance is a scalar quantity, speed is also a scalar quantity. I'll explain you why speed is a scalar quantity, we are going to study it up next. Whereas time is also a scalar quantity. See, when we measure time, do we talk about direction? Are we talking about time flowing in forward direction or backward direction? No, time does not have direction. It's a quantitative value which only has numerics, and it goes on. We cannot study it in reverse direction, or there is no direction to time. So simple, it becomes scalar quantities. So all of these are scalar quantities, 1, 2 and 3. These are scalar. Now let's talk about vector. Velocity is vector. Velocity is vector. Even displacement is vector. How do we know it's vector? Basically, these are what? These are quantities which have direction, okay. So yeah, okay, that sums up scalar and vector for the day. Now let's talk about the most interesting topic which comes up next in this chapter, and that is called speed. Yes, we all know speed. Speed looks, feels fantastic. You see cars flying by, Formula 1 cars, bikes going at a very good speed, planes flying and everything. They have speed. Okay, speed means traveling at a very faster rate than as compared to other people. That is what anyone would say if I say it in normal words. But if I want to explain it, okay, or give a definition for it, some people find it difficult. The reason is because you cannot explain speed just like that. Let's find a better way to study speed. Let's take an example right over here. Okay, let's take an example. Okay, let's say there are two guys racing. Okay, so we have guy A and then we have guy B. Both these guys you can see are racing, and both of them have to cover a distance, that is they have to move from this point to this point, okay, to the finish line. The length of the entire track is given to be 100 meter, okay. Now the person who has more speed is gonna win. But what is speed is, to understand that, this example is the best way to understand this. Let's say the first guy covers this entire track, okay, runs through it and finishes it up, okay, in about 20 seconds. Simple, he finished it up in 20 seconds. Whereas the other guy takes a time of about 25 seconds. Now everyone knows the guy who took less time, which is the first guy right over here, okay. You all will tell me, sir, he won. Why he won? Because obviously he covered, or he ran through the entire track in the least time. But how do you put it in words? How do you put it down on paper? How do you explain it? Okay, the explanation is very simple. In physics, formula helps you with the definition gives you the formula, and that is what we're going to look on to over here. You see the definition of speed. Now these are my definitions, okay. This is how I like to explain. These are not the ones that you're supposed to write in exams. The ones that you write in exams should come from your textbook. Mine are universal definition that comes from, the best of best examples. But yeah, the definition for me of speed is nothing but the distance covered in unit time. The distance covered in unit time. Now let's talk about, first we are talking about the distance being covered. We are talking about distance being covered in unit time. Now people don't understand what unit time means. Unit time basically means comparing, okay, or basically putting time, comparing any phenomenon happening with respect to time. Okay, same thing will happen when we say rate. Rate means comparing to time, and when I say unit time, that means unit time is basically 1 second. We are going to talk about that also as we move up ahead. So the formula of speed is nothing but distance covered in unit time. Simple, very simple. It's right over there. The formula is distance covered in unit time. Okay, now how unit time is, basically we're going to divide it and we get 1 second in the denominator. Also let's talk about its unit. Now to also get the unit, you use the formula. So the formula for speed is distance upon time, right? The SI unit, now when I say SI unit, people don't understand. SI unit is System International, that is System the Internationale. System the Internationale, coming from France, is organization for all the physicists and chemists and all the mathematicians in the entire world. Okay, found out in around 19th century, which was the main idea was, whenever you're doing scientific calculations, okay, you will always be using some set of units. Okay, and according to them, distance is supposed to be measured in meter, okay, whereas time is supposed to be measured in second. All right, this gives the unit to be said as meter per second. You can also write it as m by s, or you can also write it as m s raised to minus 1. Now why m s raised to minus 1 is m upon s. Whenever a denominator comes top, its power becomes minus. S already has a power of 1, right? When it comes up top, it becomes m remains 1 because it is already on top. S becomes s raised to minus 1. Okay, this explains it. Okay, definition. Now let's come back to our example. Let's talk about both of these guys. Okay, let's talk about both of these guys. Let's see who's faster. You're gonna prove it, right? Who's covering more distance in 1 second? We are talking about unit time. Unit time basically means 1 second. So who's covering more distance in 1 second? Let's talk about it. Okay, for both the distance is gonna be 100 meter, and इसके लिए भी the distance is gonna be 100 meter. Let's talk about it. Okay, now for guy A, speed for guy A will be given by distance upon time. The distance that he is covering is how much? 100 meter, and the time that he is taking to cover that distance is 20 seconds. Let's divide it. Okay, 0 0 gone. Okay, 2 1s are 2, 2 5s are 10. So this guy's speed is covering about 5 meter in 1 second. That is what meter per second means. In 1 second, how much distance are you covering? If you're covering more distance in 1 second, that means your speed is higher. That is what we're going to study in this now. Okay, let's talk about the guy B. Let's talk about his speed. Okay, same formula, distance upon time. Okay, let's talk about it. The distance that he's covering is again 100 meter, but he's doing it in time 25 second. You know, obviously he's slow. Let's divide this. 25 ones are 25, 25 fours is 100. That gives you 4 meter per second. That means he is traveling 4 meter in just 1 second. Whereas this guy is traveling, the A guy is traveling 5 meters in 1 second. This B guy is traveling in just 4 meters in 1 second. You know who's faster. Obviously the guy A is faster, because in 1 second, that is unit time, the person is covering more distance. That is what the definition of speed also says. The distance covered in unit time. In unit time means 1 second. 1 second, in 1 second, how much distance you're covering? If you're covering more distance, your speed is more. If you're covering less distance, your speed is less. That is what the definition and that is what the explanation to distance is. Okay. Now let's move on. That is what the explanation and that is what the entire whatever we have studied is for speed. Now let's talk about displacement. You see, displacement is also the same. Displacement is similar to speed, but it has direction. It has direction. That means See, speed, if you look over here, speed, both the units which are used, both are scalar. Distance is a scalar unit, time is a scalar unit. That makes the entire unit speed to also become scalar. But when we talk about velocity, you see, velocity is like speed, but it has direction because it has displacement in its formula. And displacement is a vector quantity which has direction. So automatically that makes displacement also a vector quantity. We're going to talk about velocity, denoted by letter small v. Let's talk about it. Again, example. Okay. Let's take two guys again. Guy A, we have guy B. Now, both of them are displacing themselves. Now, you'll tell me, sir, same thing happened on top. See, speed and velocity can be same. Speed and velocity can be same if distance and displacement is same. Distance and displacement are same when an object travels in a straight path and does not come back. If an object is traveling from A to B, suppose it starts at A and stops at B, it is a straight path. Okay, the length of the path is 360 meter, suppose. So the distance is gonna be 360. And the displacement is always also displacement given by letter S will also be equal to 360 meter. Why? What is the reason? Because the path taken is a straight line. It's a straight line path, right? Get my point? There's no going left or right or anything, going away from the path. No, nothing like that. It's just traveling straight. Okay, that is when distance and displacement. In races, obviously you travel straight. That is why we can take it as an example for distance and displacement both. I say both of them displace themselves. The first guy displaces for around 100 meter once again. This also guy does it for 100 meter. Okay, same funda. Okay. However, the definition and everything changes. You see, definition wise, velocity is the displacement occurred in unit time. Let's talk about it. Displacement occurred in unit time. I explained it to you before. Unit time means you're comparing the entire funda and dividing it with time, okay, to find out in what time any instance or anything is happening. Second thing is we're going to talk about displacement. Displacement is given by letter S. So it gives you the simple formula. The formula says velocity is displacement S upon time. Simple formula. Okay, it's displacement upon time. So distance upon time is speed, displacement upon time is velocity. Okay, now if you find out the velocity of both these guys, okay, let's talk about this person. First person does it in 20 seconds. The next person does it suppose in 30 seconds. Okay, let's find out for both of them again as we did before. Okay, for guy A, I will say velocity is displacement upon time. Okay, also yeah, let's talk about its unit. The unit is gonna be again meter per second. Okay, how meter per second? Because see, even if it's displacement, it is always covered in meter. Displacement is measured in meter. Okay, and time obviously you have in seconds. Okay, so the unit is also meter per second. It is same as the speed. The only difference over here is displacement has direction, distance does not have direction. So velocity has direction, distance does not have direction. That's the main difference that you guys can see right over here. Now that gives you the unit obviously right over there. Let's continue. Let's move up ahead. Now displacement over here 100 meter. 100 meter in what second? And you have it in 20 seconds. 0 0 goes to 1 5 you have velocity as 5 meter per second. Now the sign is not over there, but you already know it's in positive, it's in forward direction. In case they give you the displacement is minus 100, then you have minus 100 upon obviously upon 20, and then your answer will become minus 5 meter per second. Now this minus 5 meter per second means it is traveling in opposite direction. If the motion was this way, it's traveling in opposite. That means if the person is supposed to go this way, he's going this way. That's why it's minus. You understand? Okay. You get my point, right? Let's talk about this other guy. Suppose iska bhi minus le lete hain, chalo. Okay. The formula again becomes what? The formula will be velocity for B guy. Velocity is displacement upon time. That is velocity, the displacement is minus 100 meter upon 30 second. We'll divide this. 3 ones are 3, 3 threes are 9, 1 is your remainder. Put a point again. 3 threes are 9, 1 is the remainder. Just two numbers after the decimal. That's all. Don't go much up ahead. So you get minus 3.33 meter per second. Now, do not look at the signs. Do not look at the signs. Okay, signs in physics, as I'm already told you, and I'm telling this to you again. The signs in physics just show you direction. They are not over here showing you values. Now you will tell me, sir, minus 3.33 is bigger than minus 5. No, that works in mathematics. That is the number line and everything. And also when you do calculation with numbers, okay, integers and whatnot. Not integers, sorry, the entire number line. But if you talk about in physics, we do not use signs as a part of your number. There are other values. So over here, phi is bigger. So phi is going to be bigger. The reason is because it is the part of the magnitude. This is magnitude. Okay. Even this is magnitude. If you compare both of them, obviously 5 meter per second is higher. So even though it is happening in opposite direction, that is in this direction. Suppose I say this is positive direction and this is negative direction from the center. So this guy is running faster in the negative direction than this guy. Simple. The direction, that's all. So this guy is faster than this guy. The velocity is higher. That's the only difference between speed and velocity. Speed does not have direction, velocity has direction, and that changes everything. Alright, so that explains your speed and velocity. Okay, as you guys can see right over here. Okay, yeah. Speed is total time distance traveled upon time taken. Okay, you can see the SI unit is given as meter per second. CGS is a smaller unit. SI is based on MKS, that is meter, kilogram and seconds. CGS is centimeter, grams and seconds, which is centimeter per second. We do not use it. What we stick to is meter per second. The distance traveled in one direction by an object is called its velocity. You can see the definition right over here. Okay, whereas for speed, you have the definition, I think so. They have not given the definition over. See, they've given the velocity ka definition, which is right over here. Speed, I think so, they haven't given the definition, but you can use the definition that I have given you, the distance covered in unit time. Displacement that occurs in unit time is called velocity. The distance covered in unit time is called speed. Okay, you have the formula for velocity as well over here. Okay, so next time we're going to move up ahead and we're going to look at this one example from page 1. Okay, we're going to look into it, we're going to solve it, and we're going to find, you can try it on your own if you want, it's very easy. They're going to talk about distance upon time, which is speed. Then they're going to add up the total distances, that is they're going to see how much is the final this thing. We're going to talk about it, and then they're going to find out velocity using displacement. Okay, right, so we're going to talk about this, then we'll look at some effects and whatnot. For today we stop over here. Okay, thank you so much for watching. Okay, please do like, share and subscribe if you find this very informative and you like for it, and for further details you can contact us. Until then, bye bye, take care, have a nice day, I'll see you soon.